So my name is Jeff Palmucci, and I run the machine learning group at TripAdvisor, and be talking about location classification. And by locations, we mean any of the hotels, restaurants, or attractions that appear on the site. A couple of notes about the machine learning group. We work on a bunch of different applications across the company. I've got a lot of them listed here, and I'd be glad to talk to anyone about these offline. But in any case, we do have an engineering blog where we talk about several of them at engineering.tripadvisor.com, and I encourage you to check it out. Okay, so what do we want from this project? What is the output of it? Okay, what we want to do is we want to annotate all the locations that appear on our site with these tags. Okay, tags are a simple binary relationship, and we will use them to mark hotels as either romantic or not, or family-friendly or business-friendly. For restaurants, we'll use them to mark whether it's a Chinese restaurant or an Italian restaurant or a steakhouse. Is it good for business? Is it good for families with children? That type of stuff. Do people typically go here for breakfast, lunch, or dinner? So it's really any kind of relationship that we want to associate with a particular location on the site. And some example use cases, we use it as filters so that you can cut down your search to a particular set of locations that you're interested in. And we also use it on the location listings so that we can, does this mouse work? Yes, so that we can highlight things that a particular location is known for. We're also going to be using it in site search pretty soon. Okay, so what do I mean by at scale? Okay, we have millions and millions of locations and hundreds of tags. That's a lot of data to push around. Okay, and it's a very interesting big data engineering problem to solve. We use Apache Spark, but that's not really what I'm going to be talking about today. What I'm going to be talking about is not the machine cost of putting these things together, but the human cost. How do you manufacture these things with little overhead because there's hundreds of relationships that we want to call out. Okay, and if you're interested in talking about the big data stuff, then come talk to me offline because it's actually pretty cool work. So when we chose the algorithm, our violin may not be a great violin, but it's definitely very streamlined. We needed several requirements. One is, like I mentioned before, we have very large data sets and large numbers of models that we want to build, so it has to be an efficient algorithm. Most of the informative features that we have in any of these models is from the free-form text that we have in our large collection of reviews. So it needs to be able to handle natural language features very well, lots of features. Crowdsourcing requirements. We have a huge user base. But using this huge user base enforces some constraints on the algorithm that I'll talk about later. And in addition to getting a yes or no answer, it's important for us to get a probability estimate out of the algorithm. So knowing that we don't know is a very important part of this process. And for those of you who don't want to wait till the end, we use a semi-supervised form of logistic regression. Okay, so how do we gather the training data? Basically, tagging is a supervised problem. As I mentioned that we use a semi-supervised algorithm, but it is a supervised problem at its core. And when we were first beta testing these tags on the site, we used the Mechanical Turk to put together a data set, a gold data set that we can use to train on and get these things up and running very quickly. Of course, we switched to crowdsourcing later on for several reasons. The first is that site users, have actually been to the location. We ask for the answers to these at the end of the writer review form, so we know that the person has actually been to the place. Where a Mechanical Turker is going to have to do research online and try to draw a conclusion from that. And of course, if we have a user that is actually interacting with the site and submitting a review, we know that they're very engaged users and are going to put some thought into the votes that they put in on the particular tag questions. And of course, there's many, many more of them, millions. So this introduces several challenges. Okay, the first one I want to talk about is defining ground truth. When we first started collecting data through Mechanical Turk, what happened was an application expert would think really hard about what it meant for a particular relationship and wrote up a description that that would be handed off to the Mechanical Turkers that they would read and try to meet that definition and as closely as possible. And here's the actual definition that we used for a charming hotel. And you see that there's quite a bit of information in there, quite a few requirements on what we think a charming hotel should be. The problem is when you're using crowdsourced data, your users are not going to read that. You put that up in front of them, and they're going to get frustrated and just go away, and you won't get the review at all. So what do? For when we collect tagging questions, we go for a very simple statement, and we want to predict a continuous response. So instead of this big mess that you see on this previous page, what we simply ask is this a charming hotel? And what we're trying to predict is the probability that a new user that we haven't seen yet affirms that, yes, it is a charming hotel. And this is a very interesting approach because you use the wisdom of crowds to define the meaning of your tag, right? So when I'm thinking about charming, right, a single word, is this mess what charming means? Well, maybe, but not really. What charming means is what your users think it means, okay? Especially since we're using it on the site as a very short identifier, charming. What is the definition of charming? Well, that's simply defined by what all your users think charming is. Okay, so the definition of the tag, instead of being this very complex statement, is simply what your users think. Okay, and then once you get you can get a good estimate of what your users think. You can put a threshold on it based on business reasons, on what you want to, which locations you want to say are charming, which are not. And we'll pick different thresholds based on the ambiguity of the tag. Like charming, what the heck does charming mean? It's a very ambiguous concept. So you might pick a lower threshold. Whereas if it's something like, is this a Chinese restaurant? That's a very unambiguous thing, and you might pick a higher threshold. Okay, so what do I mean by the probability that a new user affirms? Okay, it's not the same as predicting from all the data that you have on the location. The issue with that is that a lot of times you'll have a user that goes to a particular location and has a particular experience, and that basically colors their view of the location, right? So if I go to the Four Seasons and the concierge is great with my kids, plays with them, gives them lollipops, whatever, does that make for that? I'm going to vote that that's a family-friendly hotel because I had a family-friendly experience, but you know what? It probably isn't. Most people probably don't have that response, right? So it's very important that we're not trying to predict what the users that have submitted the reviews think about the hotel, but what the next user that's going to submit a review thinks about the hotel. Okay. So how do we do that? Let's say that I have 3 votes on a particular location. Okay. I got a yes and 2 no's. I've got some location metadata. The hotel has a spa and it has 20 rooms total. And then I have some review text that is associated with this particular vote. Okay. When I build my training set, I'm going to drop the data that is associated only with the dependent variable that I'm trying to predict and use the rest of the data to build my training set. Okay. So the training set looks like this. I've got this yes vote, right? This location metadata, because it's not associated with the review, we can use all of it. But the review text, I'm going to drop that text that the user submitted along with the vote and use all the rest of the review text. Okay? So this gives me a much more accurate picture of what the future user would look like. Okay, and because I'm replicating the data like this, I need to use a weighted form of regression because if I don't, then I'm introducing a lot of spurious correlation that I don't want the algorithm to find. Okay, another issue, data collection. Let's say that I want to find all the vegan restaurants in the world. How do I do that? There's not very many of them, so I can't just ask. I can't just pick a random location and say, hey, is this a vegan restaurant? I'll get all no's, I will get, and that will not make a very good training set. You know, and if you do this kind of random sampling, you're also going to look pretty stupid because, you know, if someone's writing a review on Morton's Steakhouse, is this a vegan restaurant? Well, no. You look stupid to users, and you'll start to lose their trust. So what do? We just don't worry about it. We make it. We do non-IID vote collection. What we'll do is we will do a keyword search of our review text for the word vegan, let's say, and find a bunch of locations where the word vegan appears, and that will be our initial set of locations that we'll ask the votes on. Okay. There'll be 3 outcomes of, so we'll collect votes for, a week or so. There'll be 3 outcomes. One is there's still not enough in-class, votes. We don't find enough vegan restaurants, in which case we need to pick new seed locations. 2 is there's a good mix of up votes and down votes. So we'll be able to make our first training model and move forward with the process. And 3 is almost all the locations that we get are also up votes, and surprisingly, we can still build our first training model with this algorithm. So let's talk about that. Okay, so the 50-50 case. Let's say that the vegan data that we get is 50 yeses and 50 nos. It's a good training set, but when you train the algorithm, what is the algorithm going to predict for out-of-sample data? If with a logistic regression, the intercept is going to be 0, and it's going to be predict 50%, which is a ridiculously high estimate of the probability of a vegan restaurant. Okay, so we use a technique called expectation regularization that forces the model to conform to a prior. The prior estimate that we have for vegan restaurants is like 0.3% or something like that. Yeah. So what we'll do is we'll use a regularization term in the objective function in order to force the model to conform to that particular prior. Mann and McCallum state that surprisingly this technique is robust to a wide range of errors in these estimates. I can verify that that's true, which is a good thing because coming by accurate values for these priors is pretty tough. Okay, so what is expectation regularization? Okay, we penalize based on, kind of the cross entropy between the expected prediction in an unlabeled data set and the prior. Okay, so our estimate for vegan restaurants is 0.3%. What we'll do is we will calculate the average prediction of our regression in the unlabeled data set, and then we'll just penalize it based on the cross entropy of that average. That's important. The average to our prior. Okay. So you can basically picture a big hand shoving down the predictions on the unlabeled data set. Fortunately, unlabeled data is very easy to come by. So let's take a look at another example, which is almost all the data being in class. Okay, so here's a little chart that I like looking at for these things when I have very lopsided data sets. What I have is the predicted values for a particular model and the actual values. These are all out of sample, they're cross-validated. And each of these little dots, they're actually error bars, but each of these little dots is 1/16 the data in equal buckets, where the X value is the average prediction and the Y value is the average actual. And you can see that for Indian restaurants, we can't really draw a good response curve here because all the votes here are yes. Okay, but what happens with the regularization is kind of interesting because the prior for an Indian restaurant, which I think is 1.7% or something like that, is so small that regularization term acts as the opposite side of the training set, right? So even though we only have yes votes, the regularization terms force the other side of the class. So if you actually look at the Indian food model, we actually do have a lot of negative predictors. It's very hard to actually measure the error rate of this because we don't have any no votes. So cross-validating on that particular, in that particular case is problematic. We'll typically QA these models if we don't have enough data to get good out-of-sample error estimates. Okay. So that's how we build the first model. Okay, and to build subsequent rounds of these models, we simply prioritize our questions on where the model is predicting 50%, around 50%. And that's actually, pretty reliable because we have this regularization term that forces most of the out-of-sample predictions to be in a very low range. If something is hitting 50%, then there's actually a pretty reasonable chance that it is actually in class. So it allows us to take our seed locations. I mean, if you're looking for vegan restaurants, there may be a bunch of terms that call out a vegan restaurant that you don't know, right? You just have the word vegan. That gives you a small seed set. But using these models, then we can expand that seed set past the original terms that we found. Okay. So in summary, introducing crowdsourcing data to the problem adds challenges in data collection and model construction. It's completely worth it in order to get this huge amount of input from very engaged and informed people. Thank you. Questions?
So, anyone has questions? No questions. I can't believe that. Okay.
So my question is, now that you're using crowdsourcing data, how do you incentivize users? And normally with crowdsourcing, you will have that a small group of users will be very active, and then they will write reviews or review hotels and restaurants, but the big majority will not be active. So therefore, this is a bias. How do you balance this out?
The bias is not necessarily related to the dependent variable, right? So yeah, we do have very engaged users that are voting for these things, but I don't know that if we actually force the user to sit down and vote on it, we'd get a very different response for these things. We ask these questions in a couple of locations, when somebody's looking at the listing, so they're interested in the place, or when somebody is writing a review, so they're interested in reviewing the place. So that is, the data that we get is typically pretty good. Worrying about biased vote collection doesn't seem to, at least qualitatively looking at the results, doesn't seem to be a problem.
How does that differ, and you can repeat the question, how does that differ between what kind of restaurant and whether it's a good or bad restaurant? Because I would imagine that has different metrics.
In crowdsourcing data based on, so the question was...
Quality versus classification of kind.
Right. So, if we're classifying a particular place as being a good Chinese restaurant versus being a Chinese restaurant, we haven't really done any exploration into that, right? So we do ask those
reviews around quality. I would imagine that the bias question is much more important than reviews around just classification of what kind of establishment.
Well, see, not quite, because we also have lots and lots of reviews over these places, right? So we can estimate the quality of the location based on that data, but we tend to ask just the type questions in a tagging project. Is it a Chinese place? And then you'll be able to see the Chinese place, and it's got one bubble, and you probably don't want to go there. The tagging work that we've done so far is basically doesn't have a lot of sentiment in it, because we get the sentiment from somewhere else.
Yeah, I guess it was how that differs between some. The question is how your work differs from the work the sentiment guys do at TripAdvisor. It's asking questions along a different dimension, right? So it's just another piece of auxiliary information that we'll collect along with the review. Of course, we'll always ask,
when you submit a review, what was your overall impression of this stuff. But then at the end, as a second priority question, we'll ask these tagging questions. So it's kind of orthogonal in the current implementation. Yeah.
Great presentation, Jeff.
Oh, thank you.
I'm Reza Khurshidi from AIG. So a couple of questions. One of them is a very quick one. This prior, like 0.3%, at what geographical level, or is it geographical at all, do you set it at?
It is not geographical. It is global. And it is not necessarily to have a very good estimate. We actually use previous estimates for some of the tag relationships from that, and some will just hard code as swags.
Okay.
But in terms of geographic information, those are components of the model, right?
Yep.
So even though the prior is for a global prior on all unlabeled data, we will take that information into account when we're predicting the response.
The other question I have is a little bit of like a big picture question around similar concept that could be quite relevant to a lot of other fields as well, which is like the concept of having one model per question. Like, for example, if the number of questions grows, which is quite easy in a lot of industries, then, for example, you end up in a situation that the maintenance of the models could mean you've got hundreds of models to maintain.
Yeah, and that's why we use Apache Spark. It's a lot of models. And there was actually some very interesting talks in the scientific portion on how to deal with that. It may be a little problematic to try and build one combined model because the feature selection for the different models, because we have such a large vocabulary, because we have so many reviews, the feature selection tends to be very different between the models. So you may be able to gang up different tags on the same pass through an algorithm. We haven't tried that yet, and it would worry me because of the different feature selection that we have for the different models.
Interesting. Because I mean, the key question I had was around, like, do you see it being a challenge eventually, that if you have, I don't know, hundreds of models to maintain? I mean, running time using Apache Spark is a sensible solution, but in terms of a scientific validity of the resulting fit or sensibility of certain coefficients or like performance on test data and so on, checking all these over thousands or hundreds of models, is that something that you see could become a challenge in the work that you're doing right now?
It takes about a weekend to run 170 models right now, and we don't necessarily have to run, and that's on a 38 cluster, 38 node cluster with big nodes. That's not something that we don't need to retrain every tag model every week. So the first step in scaling out past not being able to run over a weekend is probably training a subset of them each week. But if we get to 1,000 models, is it going to be an issue? Yeah, probably. Maybe we'll call some. Maybe we'll take a look at some of these other approaches that try to do training of models in parallel using the same speed up. Yeah.
I'm Vadim Levit, Ariel University, Israel.
Mm-hmm.
I'm just wondering, may I use your framework for choosing, let's say, not a hotel, just a graduate school?
Yeah, so we use the framework on not only hotels, but restaurants and attractions too. It's not really key to any particular feature of the location. It's just we have these objects that we want to collect yes/no answers on, and how do we pick from a set of 1 million objects which to work on next? And
well, that, in this subject, but it's, as far as I know, people use some kind of algorithm like stable matching, for example, and things like that. What kind of algorithm are we interested in for your ideas?
yeah, it's not really a matching problem because we don't really know a lot about the users when they're using the results of this algorithm. All we're doing is trying to make it easy. It's an information retrieval thing, right? We want them to be able to find a particular set of locations very quickly based on their knowledge of the world. We're not trying to do some. It's a very different matching algorithm. I think is a very different type
But
thing.
there is some hint of matching here, because if you have a hotel overcrowded, So it's a problem for your advisor.
Right. We tend to sort hotels that aren't available down towards the end of the list.
Thank you.
Yeah.
I wanted to ask if you could expand on you mentioned having geographic features in the model, and I was wondering if you could talk a little more about like those and how that
Very
works.
simple.
Oh, I'm Evan Estel. I do machine learning at Meetup.
So very simple geographic features. What country is the location in? You tend to find fewer steakhouses in India, for example. So it'll be a negative coefficient on that. We put a lot of, besides the natural language stuff, we put a lot of metadata on these locations. The amenities that a particular place has, the rooms that as I was talking about before, whole bunch of other data that we get from feeds from our partners as predictors. Yeah.
Thank you.
So more questions?
Esther Dyson again. So how do you surface new classifications? Like if vegan is 0.3, 10 years ago it was probably 0. Does some product manager?
It is a product manager, yeah. So these are all curated. A product manager will pick out, geez, I really want to know what a product manager will do is they say, I really want to know this relationship, and then they'll give me a set of keywords that will give the set of seed locations and an estimate of the prior, and from that we'll just use that, yeah.
Yeah, I'm Sandro Kutzelin from Amadeus. So far, you had users creating the reviews, users reading the reviews, and from now you have users booking on your website.
Mm-hmm.
So you have a new dimension of validating the data that is behind, no? How this will affect the models, and what will you understand out of that?
Interesting. So what would, of course, the booking data is valuable, and we don't have a lot of it right now because we don't do a lot of booking on site right now. I mean, I guess you could use it as a predictor, as part of the, as part of the overall model, giving more weight to a particular vote. Booking would probably be more indicative, having that information would probably be more indicative of being able to predict fraud and stuff like that. So I could imagine that being a useful predictor, but the volume right now on the site is too low to do anything with it right now.
Maybe in 1 year this will really. So maybe in 1 year, when all the restaurants will really pick up, this will be a huge boost in the voting mode and.
I'm not really sure. If you get a submission for a review, do you think it's an honest opinion? And is the booking information there gonna give you a better estimate of if it's an honest opinion? I mean, we're already averaging hundreds of votes, so I'm not really sure having that extra information is going to be very important for this particular. For surfacing these particular types of relationships. We'll take a look at it when we have it. Don't have it yet.
Okay, good luck.
Thanks. Anybody else?
Hello? Does it work? Štěpán Škrob, Seznam.cz company. I would like to ask you, how do you deal with fake reviews, and how frequent is this problem? If you can tell something.
Sure, we do extensive work in review fraud detection. We use several statistical techniques and other techniques. And unfortunately, that's the one thing that I really can't talk about outside because of the whole adversarial nature of review fraud. We've got black hats and we've got white hats, and if the black hats find out what the white hats are doing, they'll work around it somehow. So the group does do extensive work in review fraud detection, but I'm not really able to talk about it. That's the only one.
Could you tell us at least how frequent this problem is?
We estimate about 3% of the reviews on the site right now.
though if I were fraudulent, I would probably be wrong about the quality, but I might not be wrong about the classification.
Yeah, it seems like there's less upside in lying about whether you're a Chinese restaurant or not, you know?
Okay. More. We have like a couple minutes for one more question.
If you'd like, I can go back to the slide of the other projects that we're working on, and we can take questions about those.
We have 5 minutes. If you
Sure.
would like to, you're welcome.
All right, so a couple of the other things that the machine learning group is doing. Review fraud detection, probably the most interesting thing that I can't talk about. Recommender systems, so we do personalization work. If you look on the site, you'll see a just for you sort order on the hotel listings page, and we use users' review history to try to infer interesting hotels. Botnet detection, this is detection of mechanical traffic coming in on thousands of IP addresses, possibly for nefarious purposes, possibly just, getting in the way of our statistics collection. We do work in listing accuracy and matching. So when we're getting feeds from our commerce partners, matching up a particular location on TripAdvisor and a particular location as mentioned in the feed is kind of a non-trivial problem. And we're starting to work on that stuff. Machine vision, identifying inappropriate photos, and unfortunately the only thing I can tell you here is what not to do, because we haven't had very good success in it. I think the problem is that recall is very important in this particular problem. So missing one doesn't really help us a lot. So we're still using humans in front of screens going in and reviewing each of the photos, and it's really amazing what people will post to a site these days. Automated data exploration. This is one of the things that we have that we talk about on the blog post, and one of the things I'm actually very interested in trying out one of the techniques in the scientific section, the additive regularized topic models. We use a different clustering approach to try and identify what people are talking about in a particular geography. So if you think about going to you're going to New York to book a hotel. There's a couple of hotels in New York. How do you start, right? And the idea is identify a set of collections of hotels that may give you a jumping off point. Do you tend to go see a show? Do you want something that's trendy in Soho? We'll do a clustering technique to try and identify sets of hotels that meet a particular relationship. And that will be curated by humans to get, to try and organize the geography a little bit better. Learn to rank, of course. We're starting to work with site search right now, and the site search on the site is awful. So we're just starting to work on it. So don't blame me yet. But we're starting to collect. We're going to start collecting good data on that through a rework. And of course, the natural language classification and regression stuff that I was talking about. In addition to the auto tagging stuff, we do inappropriate content classification. This is just basically not very useful reviews, things that don't have a lot of information. And there's actually a blog post on that too if you want to check it out. And we also use some natural language classification for fraud detection. So that's my that's some of the other projects that we're working on in the machine learning group. We are a small group and we are growing, so if you're interested, come talk to me.
Okay. That's the great idea.